In this video, I'm going to go over the review for our first test. The first couple questions deal with exponent properties. First thing I would do on number 1 is distribute that exponent in. When you do that, you're going to multiply. You only want each variable written once in your final answer, so the y to the 12th is good. But I do not want both of those x's there. I've got 6 on top, 9 on bottom. You could use the subtraction property. What I like to do is just say that I have 3 more on the bottom than I do on the top. And that's my final answer there. Number 2, anytime you have a negative exponent, what you can do is flip the fraction on the inside. Do not flip this fraction. But I can make that a positive 1/2 now. And then I want to distribute that exponent in, and a 1/2 power is like a square root. So essentially what I have is the square root of x to the 4th over the square root of 81, which would be x squared over 9. So that's it on the exponent property stuff. The next section is dealing with factoring expressions. Notice there are no equal signs. So the question might come up, do I need to do the whole x equals and so forth? You do not. There are no equal signs. Do not create equal signs. So we're just going to factor these. Essentially, I'm going to break this down into how many terms do you have. So do you have 3 terms, do you have 4 terms, or do you have 2 terms? And that's going to determine which kind of factoring we do. Regardless, you should always look for a greatest common factor first. If there is a greatest common factor for the entire expression, make sure you factor that out first. None of these have that situation, but I do want to check that every time that I factor. I'm actually going to go to the 4 terms first, which is number 8. Anytime you have 4 terms, you only have one method that you can use, and that is factoring by grouping. With each group, you're going to factor out the GCF, and then you are going to essentially divide those 2 things that you have there by what you factored out. And I'm going to do that with the second group as well. Taking out a 3. Whatever the sign is in front of that 3rd term, you do want to take that out. So if that's a negative, I do want to factor out a negative 3 there. But I'm going to factor out a positive 3, divide those both by positive 3. What you should notice at that point in time is that what's inside the parentheses is the same. That has to be the case. Your 2 binomials then are your 2 GCFs, 4x squared plus 3. And then whatever that binomial is that's the same, that is your other factor. Okay, that is the only way that you can factor with 4 terms. Next, I'll go through if we have 3 terms. If we have 3 terms, it's kind of what I would call our traditional factoring. We're going to get 2 binomials. We're looking for what multiplies to the last number and adds to the middle number. So the way that I organize that is I put the number that we're going to multiply to on top, I put the number that we're going to add to on the side, and I'm just going to try to figure out those 2 numbers. In this case, that's negative 17 and positive 1. Number 6 is very similar to number 3, but you'll notice that it's x to the 4th. Okay, I'm going to ignore that at first. I'm going to say, hey, it's 3 terms. I know how to factor something that's 3 terms. I get my 2 binomials. I'm looking for what multiplies to 1 and adds to negative 2. I know that that's going to be negative 1 and negative 1. What's different is if this is x to the 4th, instead of my lead terms being just x, they're both going to be x squared. Now the directions here are to factor completely. So every time you factor something, you should look at what you just wrote down and say, is there anything else I can do with that? And x squared minus 1, which I'm going to get to when we do number 5 and 7 if we have 2 terms, but those are differences of squares, both of these. So x squared minus 1 is x plus 1, x minus 1. And I can do that twice because both of those are x squared minus 1. And that would be the complete factorization there. Number 4 is also 3 terms, but we have a lead term that is not 1. So remember, if that's the case, we're still going to do our 2 binomials. Instead of just x, I'm going to put that 6 with both of these. I'm going to multiply that lead term by the last. So 6 times negative 12 is negative 72. And I'm going to look for what multiplies to negative 72 and adds to my middle number of 1. That would be positive 9 and negative 8. do not leave your answer like that, because if you FOILed that out, you would not get what we started with. So when you do factoring and that lead term is not 1, you do need to reduce. Sometimes both of these reduce, but one of them definitely will. But you need to reduce if they reduce. And in this case, both of them do reduce. So the first one I'm going to divide by 3. This is going to give me 2x plus 3. And the second one I'm going to divide by 2, which is going to give me 3x minus 4. And that is my factorization of that. So that pretty much covers 3 terms. Again, it's just kind of like your normal type of factoring that you're used to. If you have 2 terms and there's no GCF to factor out, it is one of 2 things. It is either a difference of squares, which, hint, hint, there's a power 2, so I know that that's what I'm dealing with here. Look at your numbers. Should be using t, not x. But look at your numbers. What's the square root of 16? It's 4. What's the square root of 25? It's 5. You do 1 plus and 1 minus. So 4t plus 5, 4t minus 5. And you're done with that one. It's either a difference of squares if it's 2 terms, or it's a sum or difference of cubes, which is what we have on number 7. This is the one that everyone forgets how to do. If you have 2 terms, and one of them you see an x cubed, that is an indication that you have a sum or difference of cubes. You get a binomial and a trinomial in this case. The binomial, we just take the cube root of these 2 things. So the cube root of x cubed is just x. The cube root of negative 8 is negative 2. So typically people can handle that binomial just fine. The trinomial, the first term, I'm going to square it, and that goes first. The next term, I'm going to multiply these 2 things together, but I'm going to change the sign. So x times negative 2, change the sign, it's going to become positive 2x. And then the last thing that I'm going to do is take that last number and square it, and if I square negative 2, I get positive 4. Okay, so that is your process for getting that trinomial. Square the first, multiply them together, but change the sign, and then square the last. This looks like it might factor, right? It's a trinomial. I've got an x squared and an x, but when you do a sum or difference of cubes, this trinomial never factors, so don't even try. This is all you are going to be able to do here. So that covers the factoring. I'm going to go ahead and go down to just some operations. Again, these are expressions. We don't have any equal signs, so when we're dealing with expressions, we're simply either factoring or we are doing kind of the exact opposite. We're just trying to multiply stuff together, combine like terms, things like that. Okay, that is the task on number 9. I'm going to write out x plus 4 twice. Make sure you do that. You cannot distribute the square there. But then I would distribute that negative 5, so it's going to become minus 20x and plus 5. And then I would FOIL this out, and I would get x squared plus 4x plus 4x plus 16. I'll drop down the minus 20x and the plus 5. And then we just want to combine like terms. This is my only x squared. I've got 4 minus 20, so that's going to be negative 12x. And then I've got plus 16 plus 5, which is going to be plus 21, and that is going to be our final answer there. Numbers 10 and 11, we're dealing with fractions. So when you see these, even though they've got polynomials, you should always think about, how do I do that operation if those were just numbers? So if I had a fraction divided by a fraction, what do I do? In that case, we do keep, change, flip. So what I'm going to do is I am going to change this to multiplication, and I'm going to think about flipping this fraction. And when I do that, I'm just going to do the factoring for each of those above, where I would, like I'm going to do the factoring for the top one down here at the bottom, and do the factoring for the bottom one at the top. And that's going to show that I'm doing my flip there. What you want to do is just factor everything that you can. So whether it's whether it is multiplication or division, just factor everything that you can. So on the top, what multiplies to negative 15 and adds to negative 2 would be minus 5 and plus 3. On the bottom, what multiplies to positive 5 but adds to negative 6 would be negative 5 and negative 1. the bottom here is going to be this top part factor is going to go to the bottom here. So what multiplies to negative 12 and adds to negative 1 would be negative 4 and positive 3. And then when we do this bottom part here, 1 minus x squared, remember what you want to first do is think about that as if I flip those terms around and get x squared minus 1, I do have to factor out a negative. So what I'm going to have here is negative 1 times, and then I can factor x squared minus 1 into x plus 1 and x minus 1. So that one's a little tricky there. If the number comes first and the variable is second with subtraction, flip those, but take out a negative 1 when you do that. So now I'm just going to cancel anything that I have on top and on bottom. The x minus 5s, the x plus 3s. I can take out the x minus 1. And I believe all that I have left on top is negative 1 times x plus 1, and all I have on the bottom is x minus 4, and that would be my final answer. Okay, so again, multiplication or division, you want to change that to, if it's division, multiplication by the reciprocal of this, factor everything, cancel, and you're essentially done. On number 11, we are subtracting fractions. So when we're subtracting fractions, we've got to get a common denominator. So I've got to think about what my common denominator of these two expressions would be. And essentially what I need to do is multiply each fraction by the other's denominator. So I'm going to do multiply this left one by x plus 2. So I'm going to get 1 times x plus 2 over x minus 3 times x plus 2 minus, and then on the right side I would need to multiply by x minus 3. So 2 times x minus 3 over x plus 2 times x minus 3. Once you have a common denominator, when you subtract fractions, that denominator stays the same. So x minus 3 times x plus 2, I'm going to leave that as is. And I'm going to simplify the top here. So we've got 1x, if I distribute this 1x plus 2. We'll just call it x plus 2. Distribute this negative 2 here, and that would give me minus 2x plus 6. And then the last step there would be to combine like terms on top, which would be negative x plus 8. And then I could keep the bottom the same, x minus 3 times x plus 2. Okay, the last thing I'm going to do on this video, and then I'll just make another video for the rest of it, is number 12. Number 12, you want to rationalize the denominator by multiplying by what is called the conjugate of the denominator, which means the same exact thing, but you want to change that middle sign. We're going to do that on top and bottom. On top, you're going to distribute the 6. So 6 times 4 would be 24. 6 times negative root 7 would be negative 6 square root of 7. On the bottom, we want to FOIL this out. 4 times 4 is 16. 4 times negative root 7 would be negative 4 root 7. Root 7 times 4 would be positive 4 square root of 7. And then square root of 7 times negative square root of 7 would be negative the square root of 49, which is going to turn into just 7 here. When you do conjugates, the reason we do that is because all the square roots on the bottom are going to be gone. The two middle terms cancel each other out. Again, we said we know the square root of 49 is just 7. So on top we have 24 minus 6 square roots of 7, and on the bottom we now just have 16 minus 7. 16 minus 7 would be 9. And that could be our final answer. I would say that if you have in this everything but the square root, so the 24, the 6, and the 9, I could reduce those all by 3, which I'll do. So that's going to be 8 minus 2 square roots of 7 all over 3. That would be the same thing as this. Okay, so if you can reduce those, go ahead and do that. Okay, we'll pick back up with the rest of the review on the next video.